Trying to test my luck until everything's gone. The love is not a problem, 'cause it's all I want. I'm still sleeping on a North couch like a vagabond.
Hello, Algebra Teutonians. In this next video, we'll continue talking about how you can simplify radical expressions. This one we're going to do some adding, subtracting, and then some more multiplying, more dividing. Just to give you a forewarning, this section of notes here, I've added a few more examples that are not included in your original set of notes. So I think when we get down to examples 5 and 6, after those, you'll probably have to add what I've put in here in the video to an additional sheet of paper, or if you have room somewhere else in your notes packet, make an addendum here. There's going to be a few additional examples, again, that were not in your original notes packet, so just be aware of that. Okay, we're going to start with adding and subtracting radical expressions, and this is not going to be too terrible. If you know how to combine like terms, then you can do this. So we're going to talk about what's called like radicals. Like radicals are radicals that have the same index and the same radicand. Okay, same index and same radicand. And just like combining like terms, you can only combine terms that have the same variable and same exponent. Same goes with radical expressions. You can only combine radicals that have the same index and same radicand, or like radicals. And by that, I mean you can only add and subtract ones that are alike. Okay, so looking at these four examples right here, number one, we have 5 times the cubed root of x minus 3 times the cubed root of x. This behaves similarly to the problem 5x cubed minus 3x cubed. If I were to give you that right there, you would tell me that the answer is 2x cubed. Okay, so similarly here, this radical and this radical have the exact same index of 3, and the radicand is x, meaning we can combine those by doing 5 minus 3, which is 2. So this would give us 2 cubed root of x. Okay, number 2, we have 4 radical 2 plus 5 radical 3. Well, this problem here, if I look at my index, they're both 2. We have square roots for both of these, but your radicand here is a 2 and here is a 3. Because those are different radicands, that means we cannot combine these, and so this expression here cannot be simplified. Okay, number 3, we have 7 times the fourth root of 5 minus 2 times the cubed root of 5. The radicand is the same on both, but this time I have an index of 4 here and an index of 3 here. You cannot combine radicals that have different indexes. So this one also is a cannot simplify. Okay, finally, we have 4 radical xy plus 5 radical xy. This time, they're both square roots, so that means the indexes are the same. My radicands are xy and xy, so I can combine these to get 9 radical xy. Okay, now, one note here, and you'll see this down in examples 5 and 6 when we get to that. You should always simplify individual radicals before you add and subtract. Okay, so looking at 5 and 6 here, number 5, I have 6 radical 18 plus 4 radical 8 minus 3 radical 72. Now, at first glance, it looks like none of those are like radicals, so it looks like it would be a cannot simplify problem. However, if you think about radical 18 can be simplified itself by splitting that up into radical 9 times radical 2. And so radical 18 is really 3 radical 2. Okay, so 6 radical 18, this first term here, would be 6 times 3 radical 2, which is 18 radical 2. So I can sometimes simplify individual terms before I do my addition and subtraction. So what I did here was simplified 6 radical 18 into 18 radical 2. I'm now going to do the same thing for 4 radical 8. Okay, radical 8 can be simplified by splitting 8 up into radical 4 times radical 2, which becomes 2 radical 2. And so 4 times 2 radical 2 is going to be 8 radical 2. So that second term there, we get 8 radical 2. And then lastly, negative 3 radical 72, we can split up radical 72. That'll split up into radical 36 times radical 2, which just becomes 6 radical 2. Okay, so we have a minus 3 times 6 radical 2, which gives us minus 18 radical 2. Okay, so now I've split up, I've simplified each of my individual radicals, and now we have a radical 2, a radical 2, and a radical 2, so we've created like radicals. So now I can combine these using the same rules I did in 1 through 4. 18 plus 8 is 26, and then subtract 18 from that, I get 8. So the final answer to this is 8 radical 2. Okay, let's try another one like that. We have radical 50 plus radical 32 minus 5 radical 18. Radical 50 is the same as radical 25 times radical 2, so that makes it 5 radical 2. 3 radical 32 would be the same as 3 times radical 16 times radical 2. 16 is 4, so that would be 3 times 4 radical 2, or 12 radical 2. And then finally, minus 5 radical 18, I can simplify radical 18 into radical 9 radical 2. So that becomes minus 5 times 3 radical 2. So that will give us a minus 15 radical 2. So now I can combine these. 5 plus 12 is 17, minus 15 is 2. So you get 2 radical 2. Okay, so once you get down to like radicals, you are basically just combining coefficients and leaving the radical the same, just like when you combine like terms. All right, moving on from there. This is where I believe your notes are going to have some additional examples. So I don't believe 7 and 8 are in the original notes packets I gave you. You're going to have to go ahead and add those in somewhere on a separate sheet of paper or somewhere where you have space in your notes. So go ahead and take it a second and find a spot for those. Okay, so for number 7 here, we have 5 times the cubed root of negative 12ab to the 4th times 3 cubed root of 18a squared b squared. So we're multiplying everything together here. So we're not combining like terms like we were in the first few examples. But I'm still going to put my like, I'm going to call it like stuff. That's not the proper term for it, but my like stuff together. Meaning my whole numbers, I'm going to group those together. So my whole numbers are 5 and 3. So I'm going to be multiplying 5 and 3, and then I'm going to group my radicands together. Okay, so you know multiplication. Okay, the multiplication property says if I have a radical of a product, I can make that the product of the radicals. So for instance, cubed root of negative 12ab to the 4th, I can split that up into cubed root of negative 12 times cubed root a times cubed root of b to the 4th. Okay, that's what that property says. So I'm just going to go ahead and do that. And I'm going to do the same thing to the second radical and put like things together. So for instance, I'm going to do cubed root of negative 12 right next to the cubed root of 18, which I'd get from the second radical. And then I'm going to do the same thing with my a's. So I have a cubed root of a from the first radical. The second radical has a cubed root of a squared. So I'll put those together. And then finally, I have a cubed root of b to the 4th from that first radical, and a cubed root of b squared from the second. And that just makes it a little bit easier to see how you can put all of this together. So starting out on the left over here, 5 times 3 we know is going to be 15. And then we have a negative 12 times 18. So this is going to give us cubed root of negative 216. We have a cubed root of a times cubed root of a squared, which would be cubed root of a cubed. And then finally we have a cubed root of b to the 4th times b squared, cubed root of b to the 6th. Okay, so now that I've multiplied my like variables and like numbers together, now I can simplify what's left. So I still have my 15 out here. 216 is a perfect cube. Okay, we know that if you take 6 cubed, you get 216. So the cubed root of negative 216 would be negative 6. The cubed root of a cubed is just a. And the cubed root of b to the 6th would be b squared. So your answer to this one would be 15 times negative 6, which is negative 90. And then we have a b squared. Okay, let's look at number 8 here. For number 8, I have 2 times the 4th root of 8x cubed y squared times 3 4th root of 2x to the 5th y squared. So I'm going to do the same thing for this one that I did number 7. I'm going to split up and group as needed. So I'm going to put 2 times 3 together. Then I have a 4th root of 8 times a 4th root of 2. I'll put those together. I have a 4th root of x cubed. In my first radical, second radical has 4th root of x to the 5th. And then finally with my y's, I have a 4th root of y squared and another 4th root of y squared. Okay, so 2 times 3 we know is 6. 4th root of 8 times 4th root of 2 would be 4th root of 16. 4th root of x cubed times 4th root of x to the 5th. That would be 4th root of x to the 8th. And then finally 4th root of y squared times 4th root of y squared would be 4th root of y to the 4th. So we end up getting 6 times 4th root of 16 is 2. The 4th root of x to the 8th is x squared. And the 4th root of y to the 4th is not y, but the absolute value of y, because we have an even index, even exponent, and your resulting exponent is odd, so we need to use our absolute value bars. So the answer to this would be 12 x squared absolute value of y. Alright, moving on now. We're going to get to the last 6 examples. 9 through 14 is what they are on my sheet here. I believe these are your original 7 through 12 in your notes packet. So these should all be in your notes now, the rest of these examples here. These examples, we're just going to do some more multiplying, also some more dividing, and learn how to rationalize more denominators. Okay, so number 9 here you'll notice is a binomial, 3 plus 2 radical 5 times 2 plus 4 radical 5. This is going to behave just the same way as any binomial in that we're going to use FOIL to multiply these together. Okay, so we're going to start out with 3 times 2, which is 6. And then we'll do 3 times 4 radical 5. When you're multiplying, you multiply whole numbers with whole numbers, radicals with radicals. So 3 times 4 are both my whole numbers. That's going to give me a 12. And my radical 5 is just going to stay radical 5. So 12 radical 5 there. And then I have a 2 radical 5 times 2. So I'll multiply my 2's together to get 4. And then I have a radical 5 with that. And then finally, we have 2 radical 5 times 4 radical 5. Okay, well, 2 times 4 is 8. That's my whole part. I have a radical 5 times a radical 5, which just gives me 5. So that last term is going to be 8 times 5, which is 40. So we get 6 plus 12 radical 5 plus 4 radical 5 will give me 16 radical 5 plus 40. So your final answer to this would be 46 plus 16 radical 5. Okay, number 8, we have radical 2 minus radical 3 quantity squared. Just remember, when you see quantity squared, it means take the binomial times itself. So that means the same thing as radical 2 minus 3 times the quantity radical 2 minus 3. So radical 2 times radical 2 is just 2. Radical 2 times negative radical 3 is minus radical 6. We get the same thing on the inside. We get another minus radical 6. And then finally, negative radical 3 times negative radical 3 is going to be positive 3. So we have 2 plus 3, which is 5. And then in the middle, we have a negative radical 6 minus radical 6, which is going to be minus 2 radical 6. Number 11, I have 2 plus radical 3, 2 minus radical 3, which if you're good with your factoring, you know this is a difference of squares here. 2 times 2 is 4. When I take 2 times negative radical 3, that gives me minus 2 radical 3. And in the middle, 2 times radical 3 gives me plus 2 radical 3. So those are going to end up canceling each other out. And then radical 3 times negative radical 3 is just minus 3. So these are conjugates of each other. Okay, remember talking about conjugates? And so when you have conjugates, same terms, just opposite signs in the middle, really what you only end up doing is taking the outers taking the first and the last times each other. So 2 times 2, 4. Radical 3 times negative radical 3 is minus 3. The middles cancel each other out every single time with something like this. So we just get 4 minus 3 here, which is 1. Okay, number 12, similar concept. I've got 2 conjugates times each other. Radical 5 plus radical 2 times its conjugate, radical 5 minus radical 2. So all I need to do in this case is radical 5 times radical 5, which is 5. And then radical 2 times negative radical 2, which is minus 2. Again, those outers and those inners are going to cancel each other out, so I just end up getting 3 for this one. Okay, last two problems, 13 and 14, these are division problems, so we need to find a way to get the radicals outside of our denominators on this one, just like we practiced in the last lesson. We're going to do that by rationalizing our denominators, and here's how rationalizing works when you're dealing with radicals. It's very similar to when you have imaginaries in your denominator. Okay, you remember, you probably recall some problems from the last unit where we had something like 3 plus 5i over 1 minus 5i. And I told you had to multiply the bottom by the conjugate, which in this case would be 1 plus 5i. Okay, well, we're going to do the same thing for problems like this. We're going to multiply to get this minus radical 5 out. Since it's part of a binomial, we're going to multiply the entire denominator by the conjugate, which is 1 plus radical 5. So top and bottom here are going to get multiplied by 1 plus radical 5. And then we're going to do some good old foiling. Okay, so on the bottom, when I multiply a binomial by its conjugates, again, I just have to worry about the first and last terms. So 1 times 1 is 1. Negative 5 times negative radical 5 times positive radical 5 is just minus 5. On the top, I'll need to actually go through and FOIL. So 3 times 1 is going to be 3. 3 times radical 5 is 3 radical 5. Then we have a radical 5 times 1, which is a plus 1 radical 5, and radical 5 times radical 5, which is a plus 5. Okay, notice if you're doing this correctly, your first and last term become whole numbers, and your middles are going to stay radicals. So do some simplifying here. We have 3 plus 5 on the top, which is 8. 3 radical 5 plus radical 5 is plus 4 radical 5. On the bottom, I just get a negative 4. And so that means I can reduce, because each of these whole numbers here is divisible by 4. I can reduce this down to, it becomes negative 2 plus radical 5, but you have to have parentheses around that 2 plus radical 5. Okay, the reason being is this denominator here is a negative, and so you're dividing both the 8 and the 4 by negative, so you can either write the answer like this, or you can distribute this negative sign, and your answer would look like this, negative 2 minus radical 5. Okay, again, dividing 8 and 4 by this negative 4 means both these terms have to be a negative, or you can put the negative out front with some parentheses there. So either one of these would be okay for a final answer. Okay, last one, number 14. We have 6 plus radical 15 divided by 4 minus radical 15. And so we're going to multiply top and bottom by the conjugate of the denominator, which would be 4 plus radical 15. Okay, so for the bottom, that's going to give me 16 minus 15. 4 times 4 is 16, negative radical 15 times its positive would be minus 15. Top part, 6 times 4 is 24. 6 times radical 15, 6 radical 15, and then you have a plus 4 radical 15 and a plus 15 at the end. So do some simplifying. 24 plus 15, we get a 39 on the top, and then 6 radical 15 plus 4 radical 15 is 10 radical 15. All over, 16 minus 15 is 1. So your final answer to this would be 39 plus 10 radical 15. Okay, so any questions you have, be sure to either jot those down or shoot me an email before I see you guys the next time, and then we'll practice this the next time I see you in class. Until then, have a nice day. You're all wonderful people.